Hello students, welcome back to the next module of a chapter called electrostatics. Now students, in the previous modules we have already covered the concept of combination of capacitors. We have learned two types of combination. We have learned about series combination of capacitors. At the same time, we have also covered the parallel combination of capacitors. Now students, using those particular concepts, we'll be solving a numerical on the combination of capacitors in this particular module, right? So let us start with the numerical. It says two condensers of capacities 2 microfarad and 3 microfarad are joined in series. Find the capacity of condenser that must be joined in parallel with 2 microfarad capacitor to increase the effective capacity by 0.8, right? So let us analyze this, right? Initially, let us start with the solution. So students, here we are provided with two capacitors, that is 2 microfarad and 3 microfarad, and they are joined in series. So let's say C1 and C2 be the two capacitors, right? And these two capacitors, how are they connected? They are connected in series. Now see the diagram carefully, right? C1 it is equal to 2 microfarad and C2 it is equal to 3 microfarad, right? Now, as these two are connected in series, they must be having some effective capacity. So the effective capacity of the series combination is given by CS, it is equal to product upon sum. We have already covered this particular formula. So therefore CS can be written as C1 into C2 upon C1 plus C2. Now we know value of C1 and C2, right? So therefore I can write CS, it is equal to 2 into 3 upon 2 plus 3. Now 2 into 3 is 6, 2 plus 3 is 5. So CS will be equal to 6 by 5 microfarad. And what is 6 by 5? 6 by 5 it is equal to 1.2 microfarad. So students, when these two capacitors, that is 2 microfarad and 3 microfarad are connected in series, the effective capacity is 1.2 microfarad, right? Now let us take it further, right? This is the situation that we are having. Now what we need to find? We need to find the capacity of that condenser that must be joined in parallel with 2 microfarad. So we need to find one capacitor which is to be connected in parallel with this 2 microfarad capacitor, so that overall effective capacity, right now effective capacity is 1.2. Now this effective capacity should increase by 0.8, right? So let's say I'm assuming that let X is connected in parallel with 2 microfarad capacitor so as to increase the effective capacity by 0.8. So let's see the diagram carefully. Here X is connected in parallel with 2 microfarad so that effective capacity increases by 0.8. So let's say my new capacity or rather effective capacity is C dash, right? So my new capacity C dash should be equal to previous capacity, that is CS, plus 0.8, right? Now what is value of CS? The value of CS is 1.2. So therefore C dash should be equal to 1.2 plus 0.8, right? So value of C dash will be equal to, how much it will be equal to? It will become 2 microfarad, right? And this capacity will get once X is connected in parallel with this 2 microfarad, right? Now let us move further. Let us take this diagram ahead. In this situation, we are supposed to find out the value of X. Now see these two capacitors carefully, X and 2 microfarad. How are they connected? They are connected in parallel. And once they are connected in parallel, the effective capacity will get added up. So in this case, the effective capacity will become X plus 2, or it can also be written as 2 plus X. So here capacity is X plus 2. Look at this 3 microfarad. Now see X plus 2 and this 3. How are they connected? They are connected in series, right? And again the effective capacity C dash is given by the formula product upon sum, right? So therefore I can write C dash, it is equal to 2 plus X into 3 upon 2 plus X plus 3, right? In the numerator you can see there is product of two terms, and in the denominator you can see there is addition of two terms, right? Now students, see carefully. We know value of C dash. What is value of C dash? It is 2 microfarad. So this can be written as 2, it is equal to, now let us multiply 3. So 3 into 2 will become 6, 3 into X will give you 3X, and in the denominator 2 plus 3 will become 5. So therefore I can write 2, it is equal to 6 plus 3X upon 5 plus X. Now if you cross multiply and if you calculate, you will get the value of X as 4 microfarad in this particular situation. So students, if 4 microfarad is connected in parallel with 2 microfarad, the effective capacity, which was earlier 1.2, will increase by 0.8, which is nothing but equal to 2 microfarad, right? So students, In this particular module, we have covered one numerical, or rather very interesting numerical, which was based on the combination of capacitors. So that's it for this particular module. I'll see you in the next module. Till then, keep learning.